The name of the chapter is Acids, Bases and Titration. So first, if we take the general properties of acids and bases, general properties. What defines an acid or a base? How can we say that the given compound is an acid or a base? So general properties of acids. Acids generally they are sour in taste. They turn blue litmus red. Acids, they react with metals to give hydrogen gas, to liberate hydrogen gas. All those with those metals only which are above hydrogen in the reactivity series. And phenolphthalein is colorless. This is an indicator and it will be colorless in acidic medium. So these are the general properties of any acid, and general properties of bases will be, they will be bitter in taste and soapy to touch. They turn red litmus blue. They will turn phenolphthalein will be pink in basic medium. This is pink in basic medium. But if you take the common properties of acids and bases, common property is both acids and bases in aqueous medium, in aqueous solutions, are good conductors of electricity, because they will be ionizing, they will be giving rise to ions in aqueous solution. So both will be good conductors of electricity. Depending upon the percentage ionization of acids or bases, ionization can be to different extents. So acid will be a good conductor, it will be a good electrolyte, a strong electrolyte. If it ionizes almost fully, so almost 100% ionized. So any acid which is almost 100% ionized, we will call it a strong acid. So acids can be strong or they can be moderate. That means neither very strong nor very weak, or they can be weak acids depending upon the extent of ionization. If the acid is 100% ionized, you have a strong acid like hydrochloric acid, sulfuric acid, nitric acid, and the strongest acid possible is perchloric acid. This is the strongest acid possible. So all these will be 100% ionized. If you take moderate acids will be oxalic acid is moderate, which is ionized but not very strong. It is H2C2O4. It is moderate. Phosphoric acid is moderate. H2SO3 is called sulfurous. It is a moderate acid. And weak acids will be very partially ionized, very weakly ionized, less than 5%. They will be weak. Hydrogen sulfide, carbonic acid, all these will be weak acids. Now you have seen that we can have acid or base. But the question comes, how to find out, suppose if any solution is given to us and you want to find out whether it is acidic or basic. So how to find out whether it is acidic or basic? Then we can easily find out the pH value. pH value. pH is defined as negative logarithm of hydrogen ion concentration. or we can write it as minus log of H plus concentration, that is pH value. And suppose if you have a strong acid, so strong acids are 100% ionized. Suppose if we take 10 raised to the power minus 2 molar HCl and you have to find its pH value. So HCl is 100% ionized. So whatever is the concentration of HCl will also be the concentration of H plus ions, because it is 100% ionized into its ions. So H plus ions will also be 10 raised to the power minus 2 molar only. So when you take the log, then the power comes in the front. Minus minus becomes plus. So plus 2 log 10. And you know what is log 10? Log 10 is 1. So answer is 2. So pH of this acid will be 2. So if you know the concentration of anything, the pH is 2 means it is actually the pH scale is from 0 to 14. pH scale is from 0 to 14 and pH 7 means neutral. So pH 7 means you have a neutral solution. On this side acidic nature increases, on this side basic nature. So that means if pH is between 0 to 3, it will be quite a strong acid. 3 to 5 is moderate, 5 to 7 is weakly acidic. pH from 7 to 9 is weakly basic, then in between moderate, and from 11, 12 to 14 will be strongly basic. Suppose if you have a dibasic acid, sulfuric acid is called a dibasic acid, and you want to find its pH value. So 1 mole of sulfuric acid will give, it is a strong acid, so only in one direction we will show the 2H plus and sulfate ions. So if it is 10 raised to the minus 2, very important point, 1 mole is giving 2 moles of H plus. So that means it will be this. If you just make the pH as minus log of 10 raised to the minus 2, that is not right, because H plus will be twice of the concentration of acid. So minus log of 2 into 10 raised to the minus 2. It is also called dibasic acid. 2 replaceable hydrogen atoms it has. So now log of 2 is 0.3010. Log of this 10 raised to the minus 2 is minus 2 only. So answer becomes 1.699. This is the answer. So whenever you have a dibasic acid, always take that the H plus concentration will be twice the concentration of H plus ions. And in any solution or acidic solution or basic solution, in any solution, pH plus pOH is always 14. This is always true. pH plus pOH is always 14. If pH is equal to pOH also, equal to 7 each, then the solution will be neutral. So in a neutral solution, both these will be equal. Or you can also say concentration of H plus and concentration of OH negative ions, both will be 10 raised to the minus 7 molar each. The solution is neutral. But if you have H plus greater than OH negative concentration, then if you take minus log of this, pH will become less than 7 or pOH will become more than 7, then the solution will be acidic. So in acidic solution, pH and pOH will not be same. pH will be less than 7, pOH will be more than 7. Then you have an acidic solution. So by finding the pH or pOH, we can find out whether the given solution is acidic or basic or neutral. Similarly, if you have H plus is smaller than OH negative concentration, so here pH will become more than 7. But the sum is always 14, so pOH will become less than 7. And this solution will be basic solution. So in a basic solution, pH will become greater than 7. So from the pH value we can find out the given solution is acidic, basic or neutral. Even if we are given some salts, then also we can find out whether the salt will be acidic, basic or neutral. Like suppose if you have NaCl or copper sulfate or sodium acetate, you have to see whether the given solution is basic, acidic or neutral. So NaCl will be neutral. Why it is neutral? Because it is made up of which acid and which base? It is made up of sodium hydroxide and HCl. So sodium hydroxide is a strong base. HCl is a strong acid. So the salt is neutral. Copper sulfate will be acidic in nature because it is made up of copper hydroxide and sulfuric acid. Copper hydroxide is a weak base. Transition metal hydroxides are weak. This is a strong acid. So the resulting salt will be acidic. Sodium acetate is basic in nature. Why? Because it is prepared from acetic acid and sodium hydroxide. Acetic acid is a weak acid. NaOH is a strong base. So the resulting salt will be basic in nature. So in this way, not by testing, just by seeing that which is the starting acid or the starting base, we can identify the given salt also, acidic or basic or neutral. If it is acidic, pH will be less than 7. Any acidic salt will have pH less than 7. Any basic salt will have pH more than 7. And if the salt is neutral, like NaCl, the pH is 7. So that was in acids and bases we can identify from the pH value given like we have pH, we also have an expression for pOH. pOH is minus log of OH negative concentration. This is for finding out the pOH of a base. Under strong bases, you can have sodium hydroxide, KOH. Even magnesium hydroxide is taken to be strong base. Alkali metal hydroxides and alkaline earth metal hydroxides. Under weak bases, which are only partially ionized, the most famous is ammonium hydroxide. Ammonia plus water forms ammonium hydroxide, a weak base, or organic bases. They will also be weak, which will be only partially ionized. And if you see the titrations actually they are done that comes heading volumetric analysis. Volumetric analysis is done to find out the concentration of an unknown solution. Suppose if we want to find out the concentration of unknown solution, we have any acid or base and you want to find its concentration. It is titrated by titrating it with another solution of known concentration. Is called volumetric analysis. By finding out the volume, we will find out the volume of that solution which is having unknown concentration. So by titrating it versus this, one thing is taken in a burette. Suppose if you are doing acid-base titration, so one thing will be taken in a burette and the second thing is taken in a flask. And by titrating this, so that you have this neutralization reaction completed. Acid plus base will react to form salt and water. So if suppose concentration of acid is known and the concentration of base is not known, so you can find out the volume of base used, and then you can equate their moles, or actually we equate always gram equivalents. So by equating the gram equivalents you can find out the concentration of base. So this is called titration. One thing is taken in the burette, second is taken in the conical flask, and you add the base so that the reaction just gets neutralized. So that means you will get the neutralization point or the end point. And by putting their moles equal, if number of moles are reacting are same, then you can put the moles to be equal, find out the concentration of that base. Or otherwise, if number of moles are not equal, suppose if you are doing the reaction of sodium hydroxide with sulfuric acid, this titration, so in this equation number of moles are not same. 2 moles of sodium hydroxide reacts with 1 mole of sulfuric acid. Then you will put gram equivalents to be equal. Gram equivalents of acid will be equal to gram equivalents of base. Because if you put moles to be same, that will not be right. So more details we will do when we do the concept of normality and gram equivalents. Alright then. That we can have Arrhenius concept, we can have Bronsted concept, or we can have Lewis concept. So according to Arrhenius concept, acids can furnish H plus ions in water. While bases can give OH negative ions in water. So Arrhenius concept had a limitation that they are only defined in aqueous medium. Like HCl in water, it will give hydronium ions plus Cl minus. H plus always gets attached to water to give hydronium ion. So HCl in water is an acid because it is giving H plus ions or hydronium ions. Similarly, if you take sodium hydroxide in aqueous in water, it is a base because it will give Na plus ions, and it is giving OH negative ions. So any compound is a base if it is able to give OH negative ions. So Arrhenius concept was not proper, we can say not, it has a limitation because ammonia is not a Arrhenius base, because if you have gaseous ammonia, it can't give OH minus ions. So then the second concept came, which was given by Bronsted-Lowry. Bronsted-Lowry concept. So according to Bronsted-Lowry concept, acids are proton donors. Proton is also nothing but H plus ion only, na? They are proton donors. And bases will be proton acceptor. So according to this concept, if you see all these will be acids because they can give H plus ions. Even acetic acid, all these are acids which are proton donors. And Cl negative, sulfate ion, NH2 ion, they will be bases because they can accept a proton. But there are certain substances which can accept a proton as well as give a proton. They will be called amphoteric or amphiprotic. Like if you take HSO4 minus or bicarbonate ion, even if you take ammonia or water, all these are amphoteric. How can you say that water is amphoteric? If we take water with HCl, then water will be acting as a base because it is accepting a proton from HCl. HCl is a acid. But if you take water plus ammonia, then water will be acting as an acid because it is giving H plus ion to ammonia, which forms ammonium ion. So this is a base. So in these two reactions you can see, in first reaction water is accepting a proton, in the second reaction water is giving a proton. So it is a amphiprotic or amphoteric substance, and H3O plus becomes the conjugate base of HCl. Cl minus becomes the conjugate acid of water. Conjugate base it will be. Cl minus is the conjugate base of HCl. H3O plus is the conjugate acid of water. OH minus is the conjugate base of water. Ammonium ions is the conjugate acid of ammonia. So water is acting as amphiprotic or amphoteric, even ammonia. So if you see all these ions, HSO4 minus, bicarbonate or ammonia, even H2PO4 minus, all these are amphiprotic substances, which can give a proton as well as accept a proton. If I give you sulfate ion, that will only be a base because it can only accept. Carbonate ion, only a base. OH negative ion, only a base. Phosphate ion, only a base. But some substances can only act as an acid, like if you have sulfuric acid, only acid, it can't act as a base, it can only give. So in this way you can easily classify the given compound as acid, base or amphiprotic or amphoteric. So all these were Bronsted acid or base. Third is Lewis. Third concept is Lewis concept. So according to Lewis concept, acids will be electron pair acceptor. This is in terms of electron pair. Bases are electron pair donors. This is a very important concept, and in SAT paper we definitely get from this. These three concepts: Arrhenius, Bronsted and Lewis. Like if you have, suppose this reaction H plus reacting with ammonia to give ammonium ion. Suppose if this reaction is given to you, so H plus will be accepting a electron pair from ammonia, because after these three bonds ammonia still has a lone pair. So this lone pair can be given to H plus and both of them can share. Actually this is a type of coordinate bond, and we get this ammonium ion. So in this reaction H plus will be a Lewis acid. It is a Lewis acid because electron pair acceptor, and ammonia is a Lewis base because it is an electron pair donor, and both the atoms will share. And you know, after formation there is no difference between the coordinate bond and the normal covalent bond, ammonium ion. So you can say all these cations can act as Lewis acids. All these are Lewis acids which can accept a electron pair. Even BF3 is a Lewis acid, electron pair deficient. AlCl3 is a Lewis acid, electron pair deficient. And Lewis bases will be like ammonia is a Lewis base, it has a surplus electron pair, OH minus, even water, oxygen has two lone pairs, F minus, all these will be Lewis bases which can give a electron pair. So Lewis definition is in terms of electron pair acceptor or donor. So you can be given various compounds in which you have to classify which is acid or base according to Lewis or according to Bronsted or something. Like if you have this ammonia, and if you have to answer amongst all these three, so you will say ammonia is a Bronsted acid also. It is a Bronsted base also, because Bronsted acid it can give a proton. Bronsted base it can accept a proton, and besides these it is a Lewis base also. Why a Lewis base? Because electron pair donor. So this type of question you can get that statement type of question, that it is suppose if I give you that it is a Bronsted base because it can give a electron pair. So reasoning is not right. Bronsted base because it is a proton acceptor. That is the answer. It is a Bronsted base because of proton acceptor. Lewis base, it is Lewis base because electron pair donor. So these type of questions can be included in those statement type of questions. So that was general properties of acids and different concepts regarding the definitions of acids and bases. All right.